Hey, welcome to this Dataiku Product Days presentation. I'm Diego Solomoni, the lead data scientist for Rio Tinto Aluminium Atlantic, the team Industry 4.0. I'll have with me my colleagues José Colbert and Christophe Tremblay that will help me present to you some experience in our democratization efforts for data science and machine learning in Rio Tinto Aluminium Atlantic. So first, I want to acknowledge the importance of the indigenous people and First Nations to our operations across the globe. I want to pay my respects to their elders, both past and present. I further acknowledge the important roles they play within our communities and our business. For those who don't know, Rio Tinto is a mining company operating across multiple countries and continents. Most of our operations are in Australia with iron ore, but we also have aluminium in Australia and New Zealand. My team is located in Quebec, in Canada, where we have hydro plants, smelters, and a refinery. But you can see here there is a plural company operating multiple business units on the 6 continents. Overall, there are 55,000 employees, different backgrounds, different business units. Our aluminum business is concentrated mostly in Canada and Australia and New Zealand. In this case, we have mines, smelters, refineries, hydro plants, and one of the lowest carbon footprints of the market, given our clean and renewable energy. This presentation aims to present to you our efforts in democratizing the advanced analytics and data science within the business. It started with RTA, but before that, the data science in Rio Tinto was decentralized with multiple pools of talent. And by 2017, 2018, the global company decided to create a centralized team that would operate across all the business units. This centralized team was a success. And at some point, individual business units decided to create central and dedicated teams. So their knowledge of that unit improved and stayed. Sometimes a team dedicated to iron ore, we have to do some projects in aluminum. And even if you can share some concepts, it's not the same supply chain, it's not the same challenges. So when Rio Tinto Aluminium Atlantic decided to have this dedicated data science force to this BU, they created the Industry 4.0, where we work now. And it was around 4 years ago. At the beginning of the team, when we arrived, we had a lot of low-hanging fruits, a lot of projects that were ready for us to do, and mostly on predictive maintenance, which is not surprising because those critical equipment, they had their telemetry because control groups, PLCs, and then that telemetry, luckily, was stored somewhere in a historian. So we had the telemetry data, we had the maintenance for teams, we had the business knowledge around those equipment. So we could find a lot of projects, a lot of teams that asked for help on predictive methods. The problem is, since we were ramping up, we didn't have all the tools necessary to be efficient. It was all custom code, custom processes. So during those early years, after a while, we identified that our POCs were never industrialized. The tech stack was blocking us from advancing. So we decided, okay, let's work on that. Let's see what we can do. And by that time, 2020, we decided also to include the democratization concept because, we were about to purchase a tool or a platform why not help the business adopt? And then instead of a few handful of data scientists working on a handful of projects, having some scale in the business with operators, engineers, helping us protecting their machines. Again, in this case, at that time, was related to predictive methods. Now, then we went to the business. We decided to go with Dataiku after a few studies. And we have 1.5 years of adoption already. And it is a success. We have more than 200 projects on the platform. Our democratization, our presentation efforts paid off. We had to buy a new license because we didn't predict this success. Now, even if we are democratizing, we are sharing the access to the source systems, the power of the analytical tool, we want to control what goes to production. We want to have some sort of quality control to protect the production systems, etc. So we have automation nodes for test and prod. We installed this in a cloud account, which gave us big benefits because mostly of the independence from the centralized IT team. We decide when we want to scale up and down, when we want to have more machines or no. And we still have the governance node to give the business layer to orchestrate our initiatives and mostly organized by what we call work streams. To give you an idea of this democratization effort and the success, we have here Jean-Christophe and José that will present. Jean-Christophe is an engineer. He works closer to the refinery that we have in Saguenay. José is a casting expert. She works with the casting clients, and they are not data scientists, or they were not data scientists, but they had the business knowledge. They had the ideas, awesome ideas. They identified the projects. They had a lot of previous work, but the tooling was holding them back. Jean-Christophe, for example, worked in a project to identify bottlenecks in the refinery, and he was limited by 15 minutes of runtime, sometimes access to this data sources, integration, hard integrations, coding requirements. So when he started with Dataiku, I worked with him for a while, and quickly he grasped what the tool was about, and now he has a project that runs every 3 minutes with almost 500 data sets, identifies a lot of different metrics for the bottlenecks, writes that the information back to the historians, where after engineers downstream can consume that on their own dashboards. So it is like a virtual sensor for bottlenecks that triggers decisions downstream, and he did that by himself. Jean-Christophe, please, if you can present your project.
Hi, my name is Jean-Christophe Tremblay. I work as a 4.0 specialist at the Vaudreuil plant since 2018. Here's a little bit of context about Vaudreuil. Vaudreuil is a set of chemical plant which mainly produces alumina. We receive bauxite by boat. We then extract the alumina from the ores to supply the aluminium smelter. These plants include hundreds of pumps, valves, and other equipment to be monitored. One of the challenges at Vaudreuil plant is identifying the sector that limits production. This task is currently done by process engineering team. They update Excel file, manually adjust cells according to their perception of the situation, and then send the calculated production figure. This method has several flaws. Firstly, it can only be done at a specific moment in the day. Secondly, the technical team invests far too much time in it. And finally, the result is not always accurate and may even differ depending on the person doing the job. Firstly, this flaw results in lost production opportunities. This is where the Vaudreuil bottleneck dashboard comes into play. It's a tool that computes in real time the maximum production of each sector in the plant. The calculation is based on standard formulas accepted by the process group member and operators. The operator can then access this information, which allows them to adjust the production flow according to the limiting sector. It often happens that the flow of the limiting sector is underestimated. Firstly, this is where the project gain lies. Firstly, we are looking for reducing that loss of opportunities. Firstly, the job of the technical team is to analyze why the bottleneck sector is a limitation and address the problem. They can see what the next bottleneck sector is with the TGV. Firstly, realizing this calculation is not a simple task. The availability of programming manpower and the choice of software are the two main challenges. Firstly, the creation of the 4.0 specialist position allows having a technical person available for this type of project. This is a significant change that enables Rio Tinto to modernize its method and use its data efficiently. Firstly, however, in general, specialists are not programmers. We still lack skills to do the project. The goal is to have access to about 6 months of data history and real-time data from hundreds of spy data points. The data history is used to create the models. Real-time data is then inserted into the models to obtain the maximum production of each sector. The first software used for TGV was Microsoft Power BI. This allowed the tool to be created without need for programmer. The calculation construction was long and difficult. The refresh time of the calculation was about 15 minutes, which is too long for operation. Firstly, Dataiku then became available in our company. We immediately saw the opportunity to use it for TGV. Firstly, I learned to use Dataiku in January, and 5 months later, I had built the TGV for the entire hydrate waste plant, with a refresh time of about 3 minutes. This represents 430 recipes using almost 500 data tables. That would have been impossible without Dataiku. Firstly, thanks for listening to me and have a great day.
Thank you, Jean-Christophe. So now I invite Josette to present her work with casting. Josette also had all the business knowledge behind what she wanted to do. She had all the hypotheses, the questions, etc., but she was limited by the tools available at the time. When she came to work with us, that we presented Dataiku, she did the academy, online courses, she tested, she tried, and now she has several projects on the platform, but this one specifically was so successful, the insights were so important that she will present this in a conference later this year. So now I invite Josette to present the work she's doing with casting and hot metal.
Before diving into the details of the use case, it's essential to understand the direct chill casting process used in the aluminum production. In this process, molten aluminum is poured into a mold where it solidifies as it's gradually cooled by water. Various configurations exist for this type of casting process, but basically these include batching furnaces, inline metal treatment unit, and a casting pit. All these elements must function adequately to ensure both the quality of the final product and the productivity of the cast house. One of the critical elements in the production line is the filtration unit. This equipment is required to remove impurities and inclusion, and the proper functioning of the filtration unit is critical for the overall productivity and quality of the metal. In some cases, though, the filter could clog prematurely and the casting must be immediately stopped. When clogging happens, it disrupts production, leading to unplanned stoppage and potentially costly delay. This specific case study is targeting filtration clogging during the casting process. It showcased the impact of the Dataiku's platform in helping engineers conduct advanced analytics to tackle this issue and minimize unplanned stoppage due to filter blockage. For some reason, one site has experienced a significant increase in the clogging frequency, leading to significant downtime and operational inefficiency. The traditional method of addressing this issue, such as manual calculation and Excel spreadsheet, for example, were limited. We couldn't handle complex data or predict filtration problem effectively, but with Dataiku engineer team at Rio Tinto, we were able to perform advanced analytics that went beyond the limitation of Excel. By utilizing Dataiku, combined with a deep knowledge of the casting process, the team successfully identified the root cause of the increased clogging frequency and implement corrective action. The integration of data analysis tools such as Dataiku greatly facilitated the identification of these critical factors and accelerate the problem-solving process. Dataiku platform empower engineers to work without needing deep coding skill, allowing them to run complex data models to solve this issue. Main outcomes are highlighted here, showcasing the efficiency gained from Dataiku's implementation. The first one is how the technical team used advanced analytics to establish the root cause of the filtration clogging and improve the process. Site achieved significant saving and gain in operational efficiency. Over 1,000 K saved on downtime, energy consumption, and disposable consumable. It also increased the safety and productivity on the casting line by avoiding unusual abort. Second outcomes highlight the process improvements achieved by optimizing filtration. Process improvement following the data analytics have significantly reduced the clogging rates, minimizing interruption in the continuity of casting operation. In conclusion, this is a great example of how leveraging advanced analytic platforms like Dataiku can help engineers in industries overcome operational challenges. By pinpointing the root cause of the issue like filtration clogging, the team was able to save costs, reduce downtime, and improve process efficiency. And all without needing to rely on specialized coding or data science skills. This success story illustrates the critical role that accessible data platforms play in modern manufacturing and process optimization. Thank you very much for your attention.
Thank you, José. So this concludes our presentation. Rio Tinto is a global company. Our experience here is related to the Aluminum Atlantic unit, but I think can be seen as an example of successful democratization. We have other engineers and operators that are using Dataiku right now. We are thinking about replicating those experiences in Aluminum Pacific, but I'm pretty sure this can be applied to our larger organization. And thanks for watching this. We are here for your questions.